You're listening to the Modern Vital podcast, which explores the relationship between environmental factors and human health. Here is your host, Dr. Ben Reeves, founder of Portland Clinic of Natural Health and creator of MVP 90, a 90-day health protocol customized to each individual health journey. Stay tuned for fun, practical, and thought-provoking health tips, along with suggestions and insights into optimizing health and preventing chronic disease through integrative, naturopathic, and functional medicine approaches. Your body is unique, powerful, and intelligent. Your treatment should be too.
So on today's episode of the Modern Vital podcast, we're going to talk about dirty electricity. And today we have the return of Kim O'Neill Lear, Director of Education and Communications at Greenwave International, one of my favorite EMF mitigation companies. And she has an extensive background in research, writing, and education, developing content, and works on product development as well at Greenwave. And she holds degrees from UC Berkeley and Stanford, and I consider her an absolute expert in electromagnetic radiation. I know she's getting certified as well as a specialist in that. Welcome back to the show, Kim.
Thank you so much. I'm so happy to be back.
It's great to have you. So, dirty electricity, I know it's a topic near and dear to both of our hearts, and I know especially yours, because this is literally the field that you live in, the world you swim in. So, for our audience who might think, oh, dirty electricity, is that EMFs? What is that? Can you define it for us?
Absolutely. So yes, dirty electricity is actually one of 4 different types of EMF pollution. It happens to be the type that we got our start in. We got our start especially in dirty electricity. As I think we talked before, there are 4 different types of EMF pollution, but we'll focus today on dirty electricity. And so, yeah, what is it? Basically, dirty electricity, that term became popularized to describe kind of these kind of surges and spikes of electromagnetic energy that ride our wiring in our buildings. And so, where only kind of clean 50 or 60 hertz, conventional AC electricity should be. And when I say 50 or 60 hertz, that's just the frequency at which regular electricity oscillates. And so dirty electricity kind of refers to all these other frequencies, usually higher frequencies that are riding our wiring these days. In addition to what's supposed to be there, we got all this, what I like to call electrical trash there. And it's kind of interesting. It's not a brand new problem, but it is a problem that has increased exponentially in the last, I'd say, 20, 30, 40 years. And primarily with the advent of energy efficient lighting and appliances, and also the whole electronics revolution. And so the way dirty electricity is produced is basically, it's kind of a byproduct or a side effect of how a lot of our modern devices use electricity. So lots of things these days don't use electricity as is, meaning as it's provided to us by the utility company. Most devices have to change or manipulate electricity in one way or another in order to operate. So lots of times, rather than drawing electricity in a nice continuous stream, they're drawing it in bits or pulses by turning the flow of electricity on and off repeatedly, sometimes thousands or tens of thousands of times per second. They're also having to kind of change the alternating current that's provided to us by utility company to direct current. And they're also often changing the voltage characteristics. So they're having to lower the 120 volts down to much lower voltages that electronic equipment and other equipment can handle. And so it's all of these types of, processes of manipulation and changing electrical current that creates lots of interruptions in that smooth flow of electrical current. And that is what creates what's known as dirty electricity, which are these surges and spikes of electromagnetic energy known as harmonics and voltage transients that then get conducted onto our wiring. They travel throughout, homes, via wiring. So once dirty electricity is generated by a piece of equipment, a little bit of it will radiate off into the kind of environment as kind of higher frequency electric and magnetic fields, but a lot of it is going to be conducted back onto your wiring, where it can spread, throughout the circuits in your house via the wiring. It's also going to travel up and down any power cords that are connected, into electrical outlets. And it can even move from one building to another building via power lines. And other means. And so the dirty electricity that I produce in my home can get, end up in my neighbor's home and theirs can end up in my home. So that's kind of like in a nutshell what dirty electricity it is. It's, just to summarize, it's kind of all of these higher frequencies that are riding our wiring. They travel, once they're created, they can travel throughout a building. And as they travel, whether it be along, the building wires that are in our walls, kind of ceilings, under our floors, along power cords or power lines, they're emitting these higher frequency electric and magnetic fields, higher than the 50 or 60 hertz frequencies that you get from just regular electricity. It's these higher frequency fields radiating out into the environment. And the other thing that kind of makes these fields different than your 50 and 60 hertz fields is they're not a smooth sine wave. They're a very kind of erratic, chaotic waveform, which is what kind of experts believe is what makes them particularly bothersome kind of to our bodies. And as I know we discussed when I was here last time, there's lots of different health effects that are associated with dirty electricity and other types of EMF pollution. They can affect us at a cellular level, causing all kinds of interruption in signal and communication that then have downstream effects, unpleasant symptoms like headaches or memory loss or brain fog or and then downstream effects, potential cancer and other types of diseases. So there are kind of a lot of good reasons for us to be aware of dirty electricity and other types of EMF pollution. And while there's still plenty of research to be done on dirty electricity and other types of EMF pollution, there's certainly enough already to suggest that we should exercise precaution and take steps to both kind of understand what our exposures are so we can measure dirty electricity in our environments. And then there's plenty of steps that you can take to actually reduce this type of EMF pollution in your environment.
So Kim, I know that like 50 to 60 hertz is like that sine wave you mentioned. Are we talking about then the technologies that are basically manipulating this sine wave that exists sort of in our wiring, and then that's the dirty electricity? Or is there also a lot of dirty electricity already in our wiring, in our systems, even before we connect, like a CFL or a compact fluorescent light bulb to that electrical source? Does that make sense, my question?
Yeah, no, I think I understand. So it's a good question. So if I take any building these days, if I take my home, for example, and if I were to take dirty electricity measurements, chances are, the dirty electricity that I read on my wiring is coming both from things I have running inside my environment, and we can get into sources. I'll give you some example of sources. So different kinds of equipment and appliances and devices, that I have running inside are going to generate dirty electricity that's riding my wiring. But if I were to get rid of all of those things, let's pretend I could for a minute, which I probably couldn't. It's too hard these days. We're also getting dirty electricity that comes in off of the grid. So dirty electricity that's generated in other, buildings or by, electronic or even like, for example, cell phone towers, that cell phones deal with a whole different type and towers deal with a whole different type of EMF pollution called RF radiation. But the towers themselves run on electricity and have switch mode power supplies. And so they're also generating dirty electricity, which can then get onto the power grid and be one of the sources, of dirty electricity that's traveling into our homes, from the power grid. So we have kind of an external source, which is what's coming in the power grid, kind of enters our homes and our branch circuits, in our electrical systems via the power lines. And then we're also generating our own dirty electricity inside our own homes based on the things that we're using. And so some examples, the most, some kind of the biggest offenders these days are things like your energy efficient lighting. So compact fluorescent light bulbs, your any low voltage like halogen bulbs, a lot of LED bulbs. LED bulbs are a little bit of a mix. There's some that seem to run at 120 volts and don't produce dirty electricity or have some built-in filtration. And there's some LED bulbs that are still worse than compact fluorescents. It's kind of a mix. Light dimmer switches, that we use to create great mood lighting and whatnot, they generate a lot of dirty electricity. Any equipment that's got an electric motor, so things like refrigerators, HVAC equipment, blenders, mixers, juicers, air filter systems, all kinds of things, anything you can think that's got an electronic motor. or electric motor, power tools. There's lots of examples. And then things that include a transformer or a switch mode power supply. Those are the components in a lot of electronics that have to change the alternating current to direct current or tamping down the voltages. And so anything that includes especially a switch mode power supply, so computers, printers, gaming systems, you name it. Most
and that would also include like a solar panel inverter, right?
Exactly,
because it's converting that AC to DC.
Yeah.
Like I got one in I've got one in my house, and I'm so grateful that it's still pretty close to my bedroom, but it's maybe 50 feet, I'd say, which is probably still too close. But 50 feet as the crow flies is a lot better than 20 feet, right? I mean, when you're talking about an inverter.
And the inverters, and there's inverters, can be differences in terms of some inverters can create a lot of dirty electricity. Some are a little bit better, in terms of don't create quite as much or have some kind of filtration. So it's sort of mixed, but usually you're going to get a lot of, dirty electricity related to a solar power installation. I was going to get to those. So your solar power installations, wind turbines, and the inverters that they use, your car charging stations, smart meters, all of these kind of devices or equipment generate a lot of dirty electricity. And like I said, that's what a lot of that gets conducted back onto power lines or onto the wiring in our house, where it likes to travel on hot wires and distribute itself widely. As it's traveling, it's emitting these high frequency or higher frequency electric and magnetic fields that are sort of chaotic fields in nature. They're not a nice smooth sine wave field, and even those can be, detrimental, but it's that agitating kind of like chaotic waveform that seems to make dirty electricity a little bothersome to people's systems.
So I brought my tri-field EMF meter here, which I know you guys use as well. If I'm plugging this into my mains, am I then measuring the dirty electricity, or am I also measuring RFs and MFs and all the other stuff?
Yeah, so the tri-field is, typically a handheld meter, and so it's measuring AC electric fields, AC magnetic fields, and radio frequency radiation. It's not a great tool for measuring dirty electricity for a couple reasons. It's got doesn't necessarily cover the whole frequency range of dirty electricity frequencies. It's not sensitive enough on the low end, meaning it's not able to pick up like readings that would be considered of concern in relation to dirty electricity. It just doesn't have the capacity to pick up readings at that low level. And the other big issue is that it's not able to separate and read separately like dirty electricity fields, AC, magnetic and electric fields, from the 50 or 60 hertz fields of regular electricity. And what's interesting is in any environment, those 50 and 60 hertz fields, in terms of their amplitude or strength, are going to be the predominant field, present, in a room. However, they are, you have a sine wave as compared to the kind of more chaotic nature of dirty electricity. And so you can't measure dirty electricity very well with a meter like that, most handheld meters. And that's one of the difficulties with, we're kind of branching into measurement. The two primary ways, or kind of main ways of measuring dirty electricity, are to kind of measure what's actually traveling along the wiring, because that's going to be a good indication of what's going to radiate then off of the wiring. So you can measure what's on the wiring, and then you can measure kind of, ambient fields in the air. And so when you're trying to measure ambient dirty electricity fields in the air, it's tricky. You can do it, in a sense, you can do it with an AM radio, like a portable AM battery operated radio. If you set it like kind of on a off station, so kind of to static, usually at the higher end, of your dial, but not on a radio station, you're reading static. And you don't get an actual dirty electricity level reading in terms of how much dirty electricity, but you can use it to kind of help you identify sources. So if I'm walking around with an AM radio and I get near something that's producing a lot of dirty electricity, there's going to be a very noticeable difference in the static that you're hearing on the radio. Usually you're going to hear a louder buzz. Sometimes you can hear a little clicking mixed in there. And so you can, can be really helpful for identifying sources, but it's not going to give you an actual reading. And the problem with a lot of the handheld meters like a Tri-Field, or even some really great meters, like I love the gigahertz solution NFA 1000 for, and that's what a lot of instrument that a lot of professional EMF professionals use to take electric and magnetic field measurements in homes. It's a fantastic meter. It's able to measure, dirty electricity frequencies separately from your 60 hertz frequencies. So you have the ability to do that. It covers a pretty good, range of dirty electricity frequencies, but even that great tool, which costs, close to $2,000, is not necessarily sensitive enough at the low end to pick up, problematic dirty electricity readings. And so that's why, for most professionals, we'll focus on reading what's on the wiring, measuring what's on the wiring. The very best way to do that is with an oscilloscope. And an oscilloscope, because you can get the most detailed information in terms of not just the amplitude of the fields, but the particular frequencies they're riding the wiring, which helps you figure out what some of the sources might be. You can get a lot of very specific information, and you can, with special antennas, use an oscilloscope to read kind of the ambient fields once they've radiated off the wiring. The difficulty with oscilloscopes is that they're not necessarily easy to use. They take a fair amount of training and experience to use appropriately and effectively and to interpret results. And so for most consumers, the best way to measure dirty electricity, on the wiring is to use what we call a plug-in EMI meter. Sometimes it'll be called a microsurge meter, dirty electricity meter, but basically it's a meter that plugs in two electrical outlets, and what it's doing is kind of reading the dirty electricity that's riding the wiring, in that area of a circuit. So it's a pretty good proxy, and it focuses on the electric field component of dirty electricity, but can give you a pretty good idea of, how much dirty electricity is riding your wiring near that outlet. And so typically like Greenwave makes a meter like that, and we recommend to folks just, you plug it into different outlets throughout your house. You kind of take some notes, on what are my levels, does it vary by room? Is it really high in this room or really high in this area? And that taking those kinds of readings is a good baseline for, what you might start in terms of your mitigation efforts.
Gotcha. Wow. So it's a little bit overwhelming. I mean, it's like, how does one really start here? Because it's like dirty electricity is all around, and the regular consumer probably would have a hard time really knowing exactly how much. I mean, they almost just want to jump to preventing or limiting their exposure, right? Because it's all around us.
Although, I'm a real advocate. I think that in terms of, in my mind, the best kind of mitigation protocol in terms of if you're really focused on reducing dirty electricity, the best first step is to really understand the nature of the dirty electricity in your particular environment, which means taking measurements and identifying sources. And that's where a meter, like a plug-in meter, or an oscilloscope for people who are experienced, but a plug-in meter is a much more simple way for the average person, who doesn't want to learn how to use an oscilloscope to take readings. And what's really helpful is you can use the meter not just to get initial readings. There's a lot that you can do with a plug-in meter. So there's a way that you can kind of get a sense of, okay, well, how much dirty electricity does it seem it's coming in to my electrical system from the outside? So how much is entering from the power grid, versus what I'm generating inside? So your meter can help you figure that out. Obviously, you can use it around the house to take baseline readings to get a sense of, okay, my readings are super high, or they're, they seem, sort of midterm, but I notice that they're really high in certain rooms. And so that can be really helpful information as you begin to identify sources. And that's another thing you can do with a meter is you can use a meter to help you identify sources of dirty electricity in your own environment. So there's a process you can go through. If there's certain rooms that are really high, you can play with, using your meter in that room and turning things on and off, and seeing what happens to the readings to try and identify, okay, what, if my readings are really high in a particular room, what might the sources be? And so the meter is not only helpful in taking just, readings, but in helping you identify, outside sources, internal sources, and having all of that information can be super informative to then how you tackle the task of reducing your dirty electricity in your environment, and thereby your exposures to the electric and magnetic fields associated with it.
So could I actually just get a plug-in meter then from like Greenwave that could cover all of this, or would I have to do an actual like comprehensive meter plus plug-in?
Yeah, so for dirty electricity, yes, a plug-in meter for a lot of consumers is the way that they tend to go, because a lot of your handheld meters, like I said, are not going to be effective tools, to try and read ambient readings in the air. You're going to be able to do a lot more with a plug-in meter or an oscilloscope, but that's, like I said, it requires more training and expertise and time to learn how to use. So a plug-in meter for folks who are, really serious about understanding the dirty electricity in their environment, and then having a tool that can really help guide their reduction efforts. Because like I said, I always think beginning your reduction efforts with measurements, taking steps then to reduce dirty electricity, and then confirming the effectiveness of those strategies by taking more measurements and comparing before and after results is how you best, know that you're doing the job that you want to in terms of actually reducing the dirty electricity in your environment.
And what do those Greenwave plugins run?
The meter?
Yeah.
Yeah, so our EMI meter runs $135. And I know a lot of people that are just starting out, sometimes they'll get a meter like the Tri-Field, or there's other kind of what I call combination meters that are able to read more than one type of EMF pollution. But with something like the Tri-Field or, the Cornet combo meter, you're able to read, and then a plug-in EMI meter, then you're able actually to measure all 4 different types of EMF pollution in your environment. Okay, so with the plug-in meter, you got dirty electricity kind of handled, at least at the basic level. And with one of the combination meters, then you can measure your radio frequency fields from wireless radiation, and then your 50 or 60 hertz, depending where you are in the world, electric and magnetic fields associated with regular electricity.
Got it. So then sounds like I need to get an EMI next. Don't have that yet. So, I know you guys have these amazing filters. I've got them all throughout my office and my home, and they really help a lot. But I know there's a lot more we can do, and obviously that's just a starting point. It's not really gonna reach a lot. Like if I've got high voltage power lines right next to my house, that's not gonna do anything for that. So what else can we do, I guess, in terms of what's the next step?
As far as dirty electricity goes, and in fact, in my opinion, it's with any type of EMF pollution, dirty electricity included, the very first place to start is to kind of understand the sources and do what you can to eliminate or reduce sources in your environment before you do anything else. I even tell people that before they just jump into filtering, for dirty electricity, is like looking at, okay, and when I talk about eliminating or reducing sources, that can be actually looking at, okay, I know this creates dirty electricity. Can I live without it? And if I can live without it, then, then get rid of it. Or, alternatively, replacing, dirty electricity with sources with alternatives that don't produce as much dirty electricity. So, for example, two examples of that would be if you have compact fluorescent light bulbs, installed throughout your house, I would recommend swapping those out with light bulbs that don't produce as much dirty electricity. So incandescent bulbs don't produce dirty electricity because they run on the same voltage as the electricity that's provided to us by the utility company, which is 120 volts. So any light bulb that runs on 120 volts really shouldn't produce dirty electricity. The problem with incandescent bulbs is that they don't save energy like compact fluorescent bulbs do. At least, so the real old tungsten style incandescent bulbs, are the worst in terms of energy conservation, but they don't produce any dirty electricity. There are what we call like a halogen incandescent bulb. It's kind of a General Electric makes it. Some other companies make it, but they do save about 28 to 30% electricity. But the good thing is they run on line voltage, so they're not going to produce dirty electricity. So swapping out, your compact fluorescents or your low voltage halogen bulbs for incandescent bulbs, especially halogen incandescent bulbs if you can, is a good start. Also, LED bulbs. There are some LED bulbs that don't produce dirty electricity, and I always test LED bulbs because it can really vary by brand, and sometimes it can vary by model and over time. So I have, like, what my test is, I've got a power strip, just a regular power strip, not a surge protective power strip, and I have a cool little it's an adapter that basically has a 2-prong plug on the bottom and then an Edison style kind of light, fixture on the top. And that's all it is. It's literally like 2 inches high. All it has is the plug and a place where I can screw in light bulbs. And so what I'll do is I plug in my power strip. I plug in my Greenwave meter at the end of the power strip that's closest to the cord. And then I plug in that little light bulb adapter dealie, at one of the sockets on the power strip that's at the far away from the cord. And then I'll just turn, like with LED bulbs, I'll just screw in a light bulb and I'll see what happens to my dirty electricity reading. If the reading goes way up when I plug in the light bulb and it turns on, then I know that bulb's creating a lot of dirty electricity. If I don't see any change, then I think, okay, that LED bulb might be okay. And if you can find an LED bulb that's not producing a lot of dirty electricity, then, definitely go with that LED bulb. If the lighting quality is pretty good, because then you won't, you've got the energy savings and you're not producing dirty electricity. So there's little tests you can do like that. Another example of replacement is, swapping out dimmer switches for just regular on-off switches. And there's ways to create different levels of lighting by having several lighting circuits, and different wattage light bulbs, and just, like having some on, some off, and then, or all on. You can create different levels of lighting without doing it via a dimmer switch. So those are some examples of, like how you can find replacements that don't produce as much dirty electricity, or alternatives. Other things you can do is like looking at limiting kind of your length of time that you're exposed to dirty electricity sources. Because these days, the honest truth, it would be very difficult to eliminate all sources of dirty electricity in your environment or replace them, with alternatives. Because some things it's easy to do with, and a lot it's not. So then being mindful of what are some of the other sources, like your computers, your electronics, your video gaming systems, things, your television, things like that. Being mindful of the length of time you spend on them, and if you're not actually using them. So for example, if you're not on your computer, or you're not using, a video game system, so rather than just leaving it on and having it running, turn it off and unplug it. Those kinds of things help, because, even if you're not using, your computer, if it's sitting there on, it's producing dirty electricity that's going to be conducted on your wiring. And if that's traveling throughout your house, it's going to be radiating out into your environment. So even if you're sitting, across the room, but your computer's right there, you may still be getting the dirty electricity from your computer. So if you're not using things, turn them off and unplug them when you're not using them. I always, for folks who use laptops a lot, using your laptop in battery, on battery power whenever you can, and grounding it if you're using it with AC power, or you have it plugged into, if you're using the internet and have it plugged in a wired connection, you want to try and ground your computer. A lot of laptops these days come with only a 2-prong plug. So if you can, there's different ways you can ground your computer. And there's a good article by building biologist Orem Miller called Safer Use of Computers on his website. And his name is Orem Miller. And that gives you lots of ideas for how to ground your computer. Because whenever a device is grounded, it helps take some of at least the electric field component, including the dirty electricity parts, and kind of giving it a better place to go than just out in the air right at you. Let's see, creating distance between yourself and known sources that you can't get rid of, because like with any EMF field, these fields kind of, the farther you are away from the source, the lower your exposure is going to be. So if you have certain things that are still active, like an air filter. Don't have that sitting right next to the chair that you spend all your time in, or right next to your bed. Create a fair amount of distance so that it can still do its job, but you're not, right next to it. There's certain things about fixing loose connections in electrical outlets, junction boxes, your breaker panel. I know an electrician, William Holland, who does that and finds that really helps, reduce the amount of dirty electricity, traveling along the wiring. Because another source of dirty electricity outside of, all of the equipment is any arcing or sparking that you get. From loose connections. Not only can those be potential fire hazards, but they actually also create dirty electricity because they create interruptions in the flow of current. So you get voltage transients and all kinds of things. So fixing up loose connections, dealing with any wiring errors, or current that you have traveling along grounding paths in your home can also help, reduce your exposure to dirty electricity. Go ahead.
I recently got a shield for my laptop because I occasionally have it on my lap, like at home on the couch. Will that reduce dirty electricity at all? I mean, it's one of those body shield ones, that is between my legs.
Electric field components.
Yeah.
Because shielding for electric fields, it probably will help with the electric field component, not necessarily the magnetic field component. Sort of depends on the shield. Magnetic fields are difficult to shield. They don't really shield them. You usually provide and it usually requires special metal and expensive, but oftentimes the shields are meant for the radio frequency radiation that can be coming off of the computer, but it can also help with the electric fields. I generally, recommend to people, if you can get away from using it like right on your lap, have a separation like a table or, but having a shielding mat, I think definitely will help. And that's another kind of option for dirty electricity, is anytime you can shield, like, when people are building new homes or renovating their homes, oftentimes, from an EMF perspective, we would recommend shielded wiring installations, because those will help not only prevent the dirty electricity fields from radiating off of the wiring in your walls, but also just the 60 hertz or 50 hertz electric fields that radiate off the wiring all the time when circuits are live. Shielded wiring installations can help, really prevent and greatly reduce the amount of electric fields you have coming off of wiring and power cords. It's also possible to rewire certain things like bedside lamps, certain computer power cords, things like that, with shielded cords. And a shielded cord, anytime you have a shielded cord, that's going to help reduce the electric fields you have coming off of and into your environment from that cord, whether they be, the regular 50 or 60 hertz fields or the higher frequency electric fields associated with dirty electricity. And then, of course, there's filters. There's dirty electricity is a little different than some of the other types of EMF pollution, in that there are, it can be filtered. And most of the filters kind of focus in on trying to remove the dirty electricity or reduce the dirty electricity that's riding your wiring. The idea being the less dirty electricity there is, riding building wires, the less of it that's going to be radiating out into your environment as those higher frequency electric and magnetic fields.
Gotcha. A couple quick questions. I mean, just kind of going back to something you had said. A few years back, I got a couple of those molecule air filters, and I thought they were really cool at the time, but they're connected to the Wi-Fi, and it's just not a good idea to have an air filter going in my room all night that's trying to find a Wi-Fi signal. There's no way to turn the Wi-Fi off, to my knowledge. I tried. So that's one comment I wanted to make. And the second one is that my son, who just turned 2, we have an air filter going in his room. It's not connected to Wi-Fi, but it's going next to his bed or his crib, and maybe within about 2 feet of his crib. But it's like, from talking to you, I probably need to move that air filter into the corner, because it probably is emitting a certain amount of dirty electricity, even though it doesn't have the lights on.
And it's got, most air filters run on a motor, so oftentimes you can get a high magnetic field, even a 60 hertz magnetic field coming off of air filter like that. So with the tri-field meter that you have, in its standard setting, it's kind of an interesting experiment to just hold that, put it in the standard magnetic field setting, and kind of hold it right next to the air filter, see what your milligauss reading is, and then start to back away from that air filter and see like what happens to that reading, because magnetic fields, like anything, if it's a point source magnetic field like that from a particular piece of equipment, the field will tend to drop off relatively quickly. It just, how quickly depends on the piece of equipment. So, like even a dirty electricity filter is going to give off a little bit of a magnetic, like a localized magnetic field, what we call a point source magnetic field from a filter. Once you're about, 3 to 6 inches or so from the filter, then you're back down to what would be considered ambient levels in your home. So, which is usually, it depends on the home, but usually, 0.5 milligauss, would be, oftentimes, sometimes somewhere between 0.2 and 1 is sometimes the ambient level these days in homes. So when you stand next to that air filter with your magnetic field meter or your tri-field set on the magnetic field setting, notice how high the reading is right next to the air filter, but notice as you move away and at what point you get down to around 0.5 milligauss. And then that will give you a sense of how far you would want that air filter to be away from the crib. It would be much better for it to be as far from the crib as possible.
Well, thanks so much for that, Kim. I wanted to ask you one last question, which we don't have to get too far into, but do you think that dirty electricity, or to what degree do you think dirty electricity, potentially impacts our genetic expression, and is an epigenetic driver, turning on and off our genes or driving gene transcription? I know this kind of opens up a whole can of worms, but
because I don't think that, like with dirty electricity, there's been any like specific studies on that. Now, what I do know about kind of electromagnetic fields in general is we know that they can cause effects in our bodies, at the cellular level. And one, of the known effects is, damage to DNA. So, damage to DNA during replication process, that if that damage doesn't get repaired, by your body, our bodies have an ability, as you know, to repair damage that happens to DNA during cell replication, because it's sort of normal for some damage to happen, and our bodies are pretty good at being able to repair some of that. But with all of the exposures and all of the extra things in our environment these days, what I think science is or scientists, researchers are finding is that sometimes there's so many points of damage, whether they be, single or double strand breaks, that our bodies aren't always able to repair all that. So if damage goes unrepaired, then it can basically, turn into a mutation that then can get, passed on during future replication. And so the effects that has, for potential problems down the road, whether it be disease or other ill health states, increases, the more that we are exposed and the more DNA has been damaged. I know that kind of increased levels of micronuclei, have been associated with EMF exposures, and those are a huge indicator, one of the indicators for closely associated with cancer, as are other types of DNA damage. So, I know that EMF pollution, it has been shown to kind of have that impact or the potential for that impact. And so I think it's important that we kind of, be careful about our exposures. And it's not just dirty electricity. It's, there's 3 other types of EMF pollution, and it's kind of being aware of what all of them are, what the different sources are, and just starting to take steps. And I know that it can, when you start talking about mitigation, it can feel overwhelming, I think, to people, like, oh my gosh, it's like everything. So, you just kind of, you start where you can, and you start adding steps as you can. And lots of times we'll say to people, start in your sleeping area. If you can, start in the area where you sleep, because so much important regenerative work happens in your body while you're sleeping. So if you could give yourself a pretty clean EMF environment, from all the different types of EMF while you're sleeping, then you can start to pick apart, the rest of the day. But, there's lots of stuff you can do, and it varies depending on the type of EMF pollution that we're talking about. The mitigation strategies can vary. Some people will, I do get the calls like, well, 5G just went into my neighborhood, or, my neighbor has a Wi-Fi router, or, are your filters going to help with that? And I have to say, well, our filters are specifically for dirty electricity, which is one type of EMF pollution, and they're specifically targeting what's right in your wiring. to kind of try and help clean that up so that not as much is radiating out. If you're interested in reducing your exposures to cell phone radiation or Wi-Fi, the RF radiation from Wi-Fi, there's a kind of different kinds of steps you have to take, looking at using wired connections versus wireless, turning things off, modems and things like that when you're not using them. So it is a big, there's a lot to it, but I think if you start taking it a step at a time and start kind of in your sleeping area, that can be a great way to at least get the process started.
I've got a couple of patients who are airline pilots, and it's really interesting to see the impact that the cosmic rays have on their health in many cases. And I know there's a lot of research on this, but I've got them on some pretty high dose levels of antioxidants and things like that, and it seems to really help. Just ward off the oxidative stress and damage that can be. But I'd really love to know how much dirty electricity is there in a plane.
Well, and the thing about pilots, it's interesting because there are different occupations where the research has shown that just more health effects with certain occupations because of the higher EMF exposures. So I'm sure there is dirty electricity. There's also, as you say, the cosmic rays from space. There's also radar, which is another type of the radio frequency microwave kind of radiation. And so, it's an occupation where there's a lot of exposures.
Right.
Yeah.
That's very true. Well, Kim, I know we've gone a little over time here. It's been amazing talking with you, as always. Where can people, find Greenwave?
Yeah, so greenwavefilters.com. If you're interested in learning more about dirty electricity, we've got plenty of information about what it is, our filters. We also encourage people to call. I mean, we got our start kind of specializing in dirty electricity, but we recognize that there are 4 different types of EMF pollution and people have questions about all of them. And so we're in the process of branching out and trying to provide more information, more education about the different types, ideas about different strategies for reducing not just dirty electricity, but other types of EMF pollution. So we definitely encourage people, come visit the site, give us a call. We're happy to answer questions.
Well, thanks so much for joining us today. That concludes today's episode of the Modern Vital Podcast, and we'd love to hear from you. We value your feedback. If you have any questions or suggestions, please reach out to me at ben@modernvital.com, and also please leave us a review if you enjoyed this episode on Spotify or Apple iTunes. We look forward to having you join us next week for another exciting episode of the Modern Vital Podcast.